As usual, we'll go over a few examples to try to apply the proportionality theorems. So number one, you want to find the length of AB. We could apply the triangle proportionality theorem here. So this segment or line BE is parallel to this side, so it should divide these two sides, AC and AD, into proportional parts. To find the length of AB, I'm just going to let that be X. Again, basically we have our proportion already set up. You don't need to do too much work, in my opinion, to figure out the proportion. X over 5 should equal 6 over 10. And then I could write that out and solve that for X. So cross multiply, 6 times 5 is 30, divided by 10, X, which is side length AB, is equal to 3. So, I mean, really, if I wanted to, I could just write AB is equal to 3. Take a minute, maybe pause the video, try number 2 before we go over it together. So here's a proportion that you should have set up. Maybe you let AB be X like I just did. X over 2 would equal 7 over 9. You just make the proportion from the diagram, basically. And then if you solve this, 7 times 2, 14, divided by 9. I could just leave it like that, 14 over 9. This is your simplified because nothing besides 1 goes into both 14 and 9. Improper fraction. You could write it as a mixed number if you want. You don't have to. For numbers 3 and 4, we want to determine if AB is parallel to XY. So really we should be applying the converse of the triangle proportionality theorem. Okay, if these sides are in proportion, then AB would be parallel to XY. So if 3 over 4 is equal to 4 over 5, then AB is parallel to XY. Okay. 3/4, 0.75. 4/5, 0.8, even though those are close, they're not equal. Or another way you can check is 4 times 4, 16, equal to 3 times 5, 15? No. So those sides, AB and XY, are not parallel. And then you could do something similar for number 4. Check if 6 over 4 is equal to 7.5 over 5. You can do it 2 ways. Divide 6 by 4. If that's equal to 7.5 divided by 5, then AB would be parallel to XY, or you can cross multiply. 6 times 5 is 30. 7.5 times 4 is also 30. So this is what's called a true proportion. Therefore, AB is parallel to XY. And then on number 5, you want to use the diagram to complete the proportion. Starts off as UV over UW would equal XY over, and then what corresponds with UW here is XZ. Number 6, XY, this part right here, over YZ has to be blank over VW. And then what corresponds with XY here is UV. Lastly, blank over ZY. So ZY is right here, is equal to WU. So WU is this entire segment over WV right here. So it has to be this whole segment, XZ. Right. And then the last couple of examples, find the value of the variable. So you're shown that this angle is bisected because these two parts are congruent. So we're using the triangle angle bisector theorem. And then we could set up a proportion. So the proportion that you can set up right here, 9 over x is equal to 15 over 5. And then you can cross multiply. 9 times 5 is 45. If you divide that by 15, then x is equal to 3. Last example might be a little bit more difficult. I'm going to give you a minute to pause the video and see if you can set up a correct proportion and solve it. In order to set up a proportion, you could set up 9 over b. That would equal 6.75 over just this part. So you have to figure out the length of this part. If this whole thing is 14, this is b, then this segment right here, let me show you exactly what I'm talking about. Right there in red. So that segment length would actually be 14 minus b. So that's what we could set up on the other ratio. And then we cross multiply. So I'm going to show my work up here. 6.75 times b is 6.75b. That would equal 9 times the quantity, 14 minus b. Okay? And then you could distribute in order to solve for b. Because we only have one variable in there, that variable is b, we can solve that for b. So 9 times 14, 126. So 6.75b equals 126 minus 9b. So we could add 9b to each side. And then the left side is going to equal 15.75b is equal to 126. And then we could divide each side by 15.75. So 126 divided by 15.75 should get b is equal to 8 for that problem.